Hi everyone, welcome back to Adrian's Digital Basement. On today's video, I'm going to try to work on a TI99 4A, try to repair this board. The video may be a total bust, and if it is, I guess it will be a bust. All right, let's get right to it. This is a TI99 motherboard that was sent in on a previous mail call, several mail calls ago, by an unknown viewer who sent me an entire brown TI99. It was in rather rough shape, the whole case, but the motherboard didn't appear to work. So I don't remember all the specifics on the last video with this board, but I wrote on here black screen fault, which I recall was the problem. But I don't remember how much other troubleshooting I did if I just plugged it in, saw a black screen, and called it at that. So I think what I need to do is get this plugged into a monitor, make sure that it still has the black screen fault, and then use the oscilloscope or the logic probe to check some of the signals to make sure this thing is actually attempting to run, or maybe there's some other fault that is preventing it from even booting at all. So the first thing I need to do is find a power supply to run this thing, and luckily I actually have the original TI99 power supply. It's kind of an unusual connector, and the power supply here says 18 volts AC and 7.5 volts AC. So it's definitely a little unusual. Oh, and I'm realizing now that there's more to this because there's a power supply board that plugs into this cable, and that's missing, and I can't do anything without that, so I need to go find that board. All right, here we go. I had packed this stuff away for a future troubleshooting session, so I think that should be the power supply. This is an Alps keyboard with SKCC switches, very similar to the Macintosh original Mac 128, 512, and Plus series. All the keys are right here. I had taken them off to give it a thorough washing because the whole thing was rather dirty. And what's this? I have a bag here. Looks like a cartridge slot. Oh, there was a couple broken switches as well, and a bunch of screws. I honestly don't know how I didn't notice that there's literally two switches that I had desoldered and taken off this board. I think I might have a replacement, although I don't think so because these are actually the low profile switches. Compared to the switches on the Macintosh, which are high profile, I actually have a couple spares of those that a friend gave me, but none of these low profile SKCCs. And then I have the case, which I've washed and cleaned as best I can. And it's actually in pretty nice shape, as you can see here. It's got a crack right there and a crack over here on the side. So it's a little bit beat up, but that's okay because I actually have another TI99. I don't have it here with me. It's at the office where, of course, I can't get to right now with the whole human malware thing. But that one is in really good shape, and it's the black and silver one, which I think looks a lot better than this later cost-reduced one. Oh, sorry, I just realized I had my camera in the wrong mode, so I apologize for probably how terrible the video was just looking, dark and screwed up looking, but now it's in the right mode. So this is the power supply. This is where the connection is to this brick here. And then this has the power switch right there to turn off and on the computer. And then there's a connection here for the power that goes to the motherboard. So let's connect this motherboard back up to this little power supply unit. Luckily, this is a keyed connection, so even though these wires are all the same color, they are keyed. And you might notice this only has two pins in here, and while this power supply outputs two different voltages, I think that was for earlier models, maybe? Someone could probably correct me if I'm wrong. Maybe this is a later switching power supply that only uses some of the voltages because there's actually missing pins, and you'll notice here there's only two wires. Before we plug this into power, the next thing I have to worry about is the video output. And that is this DIN connector right here. Hopefully you can see that there on the camera, but it's a standard 5-pin DIN connection, very similar to a lot of other machines of this era. But one thing you have to be careful with these 8-bit machines is sometimes they give out some high voltages on these pins to run an external RF modulator. And this one is no exception. It has plus 12 volts on one of the pins. So you don't want to plug in the wrong cable and accidentally send 12 volts into your monitor. Luckily, if you just do a quick Google for TI99 pinout, in images, Google Images search, you'll find this, which is a handy chart that shows the US and the European TI99, along with the Commodore 64 and the Atari 800. If we look at the top here, 12 volts is pin number 1 there, so we want to avoid that one, but composite is pin 4, that's the yellow one, and then the audio is, I think, pin 3, So that's up at the top. And then there's not connected is white, and then ground is the pin in the middle. And the reason why I'm showing this is because if we go to the Commodore 64, I think it should be very similar. So ground pin is in the middle, let's label 2 on this one. The pin next to it, which is pin 4 on the 64, is the composite. And if we go back up to here, it's ground in the bottom, and then pin 4 is the composite, so that matches. And then the audio is pin 3 on the, Commodore 64. Audio out is pin 3, it is on the Atari as well. Now what you have to be very careful about is the Atari 800 has S-Video, Luma, and Chroma on pins 1 and 2, and I have a cable that I made for that, but if I plug the Atari 800 Chroma Luma cable into the TI99, I will get 12 volts out on the Luma signal. Not good. So what you want to be using is a Commodore VIC-20 or a Commodore 64 composite video cable, and that will work. Obviously, the Commodore 64 with Luma Chroma has extra pins, so you can't use that cable. But I just happen to have my Commodore 64 video cable. It says VIC-20 on here, and this breaks out the composite and the audio. And this is the right cable for this machine to get a video picture on my monitor here, and that's going to go through my RetroTink. All this does is upconvert the composite to HDMI so I can look at it on the LCD screen here, and I don't have to film a CRT, which always looks kind of crappy on the camera. Okay, first things first, I am going to switch the input on my monitor to make sure that it is on HDMI, and I'll get color bars. When the RetroTink has no input, you just get color bars. Okay, there we go. So I know that the RetroTink is displaying correctly, so that way if I send anything into this, it will either go black or I should see the TI99 boot up. Next, I'm going to plug in this giant brick. It's amazing how heavy that thing is. It's kind of ridiculous. And let's plug this in here. So this only goes in one way due to the orientation of the pins. There we go. And I think everything is good to go for testing. Let's turn this on. All right, so there's definitely an NTSC signal coming out of this machine, but just as before, it's just a black screen. I've power cycled it a couple times and it's just still a black screen. So if you have any kind of fault with the computer, especially an old one like this, the first thing you need to do is check the voltages. I may have done this in the first video where I unboxed this computer, but it's a good idea for me to revalidate this just to make sure I'm getting the correct voltages out of this power supply and into this motherboard. So I have the multimeter set up where you guys can see it. I have it set for volts DC. So I think what I'm going to do is I'm going to touch the ground probe or the negative to the ground that goes around this motherboard. All of this silver part here is for the original RF shielding that was on this board, and that is definitely a ground. So I can use that as a ground, and then I can just test these various pins here. There are 4 of them to see what voltages I'm getting. One of these is going to be ground itself, and then there's going to be 3 other voltage rails. So I'm just going to touch right here to these pins, and I'm going to check to make sure that I'm seeing the correct voltage rails off of this power supply. All right, so first I need to turn this on. So we got a black screen. I'm going to touch this on the ground, and we'll start on the leftmost pin, and we're getting 5.3 volts. That's a little high, but it's okay. It's within specs, probably. And then the next pin over, I am getting basically 0.00011 volts, but it's close enough to 0 volts. That is probably the ground signal. And here I'm getting 11.92, so that's the plus 12 volts that we should be getting. And I think the next one should be minus 5 volts, and that goes to the RAM chips. Minus 5.06 volts. So that looks good. And really the question is why is it a little high at 5.3 volts? And that is a bit out of spec. And I'm wondering if there's any kind of adjustments I can do. Now on this particular power supply, I see there's a little variable resistor right here, and that may be a voltage adjustment. So I'm going to tweak that just slightly and see if the voltage goes up or down. Okay, for easier testing, I have clipped my multimeter leads onto the 5-volt rail right here, and I'm going to turn this back on, and that way 5.3 volts. That way I can tweak this and adjust it without having to hold the probes at the same time. So I'm going to use a little plastic tool here, and I'm just going to turn this ever so slightly. Okay, and look, it's going down. I feel a little safer with it being under 5.1 volts. We'll just leave it right there, and I'll quickly check the other voltage rails. So I can leave the ground one connected to this clip lead here, and I will just quickly check the other 2 rails. Minus 5 still looks great. And the 12 volts is 11.9, which is great. That's still totally within spec. And then reconnecting to the plus 5 volts, we're much closer to 5 volts, which I feel much better about. So again, this little variable resistor is labeled RV1, at least on this power supply design, seems to adjust the 5-volt rail. Okay, so I'm not really familiar with troubleshooting this computer, but again, there's some stuff that you can do that's pretty much standard across all of them. One of the things is, with the machine powered on and left for a couple minutes, is go through and touch all the chips and test for hot chips. You're looking for anything that seems extremely hot or out of the ordinary. Now on a Commodore 64, a lot of the chips like the VIC-2 and the SID, they get very, very warm, just normal operation. So you do kind of have to know your computers to see if that chip should get hot or not. But typically if you have like a 74 LS Logic chip, those typically don't get warm or that hot at least. And when you feel one that's burning hot, that chip might be a fault. But something else is with RAM chips, we have 8 RAM chips that are all the same here. And if one of them is much hotter than the rest, then that could indicate a fault in that chip. It doesn't necessarily mean that chip is the problem, but it could indicate a fault. So I'm just going to go through this thing, and like I'm not familiar with this machine, and I'm just going to look for anything that seems unusually hot. One of these ICs is warm over here. So this IC right here is relatively warm. Now the part number is TM9904ANL. I'm unfamiliar with what that IC does, but just because it's warm doesn't mean it's faulty. That just might be normal activity for it. So just keep in mind that might be a fault, but I'm not holding my breath that that's a problem. So this TMS9901, this is a pretty warm IC, but it's definitely not burning hot. But again, these large size ones, it's not totally unusual that they get warm. The CPU is relatively warm, but that doesn't mean anything either. This chip up here is hot, but this is the video chip, and if it's anything like on a Commodore 64, that's just normal. They get pretty warm. I'm not going to count that as bad immediately. But again, no smoking gun with any of the RAM chips, but I do sort of suspect, I think it's either this one or this one that's a little warmer. Yeah, all these are relatively warm. Okay, so I'm going to turn the power back off on the machine. So one of the goodies that I'm lucky enough to have is a Flir One thermal camera. This is one of the older ones, and it plugs into an Apple device. It's a lightning connector, and I can actually kind of point it at things and get a good idea of the temperature. So here's a photograph of the motherboard that I took using the thermal camera, and what's especially good about it is it's useful to be able to tell if any one chip is way out of whack from a heat perspective. So there are the 8 RAM chips, and they're all actually pretty warm. It seems like the one on the end is a little bit less warm than these, but that may not be unusual. I don't know, that could be normal, for instance. But either way, if one were really, really hot, it might be glowing very brightly, like the graphics chip here, and the rest would be darker. So everything kind of seems, for the most part, okay. There's an alignment problem between the hotspots and the ICs. This blob right here is actually the CPU. The alignment of the kind of outlines and the thermal image aren't quite aligned. There's an adjustment in the software, and I didn't adjust it. So from a thermal camera perspective, I'd say nothing really sticks out for me, but really using your finger is a great way to test. The human fingers are very sensitive to temperature differences, so just pay close attention as you touch the various chips, especially if they're all the same type like RAM, and look for one that is quite different temperature than the rest. So there were comments in the comment section when I first showed this motherboard and showed that it was a black screen, where people said that it was the graphics chip that was the fault, and there's a very common failure on these machines, so I'd need to swap this out. Well, I didn't have a graphics chip to swap into this motherboard at the time, but thanks to T. Maloney on my last mail call video, I now do. Now this one does have a broken leg right there, so I can't just easily swap this into the motherboard, but I think it's still worth putting a new leg on here and then sticking it into the socket and seeing if it fixes it before doing any other troubleshooting. Especially because this chip is in a socket, so it's extra easy. It's not like I'm desoldering it from the board before I can try this extra part. So let's start by removing this IC from the socket. That came out pretty easily. I think I had used Deoxit on here before. And then as for this busted leg, I'm going to go into my dead parts bin. These are all my ICs I've removed from computers over the years. Here's a dead TI RAM chip I took out of something at some point. So I'm going to remove the leg off this IC, and I'm going to transplant it onto this one. And I have to say I'm quite lucky here because there's still a good amount of this IC leg left. It's just this thin part here that broke off. So this top part here is perfect for soldering on the new leg to. All right, first I'm going to use these needle nose, and I'm going to remove one of the IC legs from this chip entirely. I'm just going to bend it. I'm going to hold on to it, and I'm going to move it back and forth till it snaps off. There it comes. It's right off. Get this off here. There it is, right there. Oh, it keeps sticking to the needle nose. Next, I'm going to take some sandpaper and I'm going to try to sand the little bit of this leg that is still there. Just like that. Notice there's sort of a brown coating on the rest of those pins. I just wanted to make it shiny metal again so I can apply flux and then solder that new leg on. So I have a flux pen here to apply some flux. I have a set of tweezers to hold onto this little tiny leg here to help me solder it on. Hopefully it doesn't go flying off. Like sometimes I grab things with tweezers and it like shoots off somewhere into the basement. I never find it again. So first things first, I'm going to apply a little bit of flux from my flux pen here. I'm going to use one of these helping hand things just to hold the IC against the table there so it's upright and I don't have to hold it with one hand while I try to get this leg onto here. All right, here's my soldering iron and I'm just going to apply a little bit of solder right onto this. There we go. And I'm just going to put some flux onto there, this is the leg. And then I'll melt this solder here and when I touch it, oh, I'm very shaky. All right, I think that's good. It's not perfect, but it should work. Okay, so to reinstall this IC, I noticed there is no notch in this socket, which is rather annoying because, you know, you want to make sure that it's the same. And just because this chip has the notch on towards the bottom doesn't mean that that graphics chip is always in the same orientation. On some machines, like on the C128, if I recall, there are some ICs that are actually flipped around the other way. Now you will notice there's a little white painted square right here on the socket. And to me, that matches the circle that's on some ICs, like this one has one right there to indicate pin 1. So I'm going to say that it is pin 1 when it faces down. Okay, before we install this, I'm just going to put some Deoxit into the socket here. Now, my Deoxit can actually broke. Occasionally this happens if you drop it or it falls on the floor, the nozzle on the top breaks, but there was still a good amount of Deoxit in it. So I filled up these little dropper containers with a little needle. All right, pin 1 is right there. I'm going to match it up with the spot on the socket. All right, moment of truth. Will this fix it? No, that was not the problem. Or this chip is bad as well. Let's see if it gets warm because this video chip was one that got quite warm. All right, well, we're still in the same position with a black screen and a non-functioning TI99. So next step is I'm going to try to find schematics and then we'll bust out the logic probe, see what we can find out with that. Well, that's going to be it for part 1. In part 2, I'm going to break out the schematics and I'm going to start to really delve deep into what's wrong with this TI99 motherboard and try to get it working. So if you enjoyed this video, I'd appreciate a thumbs up, but if you didn't, you know what to do. Hit that thumbs down button, subscribe for more videos, hit that bell icon if you want to be notified about my uploads, and then of course, put your comments and your suggestions in the comment section below. All right, that's going to be it. Stay healthy, stay safe, and I'll see you next time. Goodbye.